In this tutorial, we're going to go over the very basics of network programming in Java. There's lots of different ways that we can implement communication between two processes running on two different machines that are connected to the same underlying IP network. But today we're going to look at the use of sockets to do this in Java. So you can think of a socket as an endpoint of a two-way communication link between two different processes running on different machines but connected to the same network. And we identify the machines themselves and the network, of course, by their IP addresses. And then we can identify a particular communication link on a given machine by what we call port number. So in general, each socket is said to be bound to a particular IP address and port. So the programmatic interfaces available for Java, available to us are very similar to the interfaces that you might have seen before with C or C++. But happily they're at a slightly higher level. When we use sockets to form a two-way communication link over the network, one of the processes involved we designate as the server and the other one as the client. And the client then is the process that actively initiates the connection with the server process, and the server process will bind to a particular port number and simply wait for incoming client connections. In Java, we implement the socket endpoint for the server process using a class called server socket, which is from the java.net package. And then in the client process, the equivalent class would be called socket, and it's also in the java.net package. So here's a very simple diagram that shows the whole process of both client and server and the respective socket related calls that they're going to make to communicate together. So the very first thing we have to do is on the server process we have to create the server socket instance. And once the server socket is created, the server process can call its accept method to wait for an incoming connection. So here we see the server calling accept. To connect to the server, the client process down here simply creates a new socket and specifies what IP address and port the server socket is blocked on its accept for. Once we create that socket down here in the client, we actually will connect, and the server process will unblock and the client process will unblock, and now they can actually communicate together doing reads and writes in a way that's pretty much the same as you would do reads and writes to a file in Java. So the important thing is right over here, when we do that blocking accept, when the client makes its creates its socket instance, then we have the synchronization point and both processes will proceed. So after they've done a series of read and writes together, it's a bidirectional stream that we have now, then either one or both of the processes can call the close method on the socket to close off or to terminate the connection. Okay, now let's look at some simple Java code to show how we would implement this. So here's my simple server class, and this is going to implement the server functionality that we just discussed. So the first thing I need to do is make sure that I've imported the java.io and the java.net packages so I can access the socket functionality. So I have here my class definition for simple server, and I just have all my code right now in the main routine to keep this very simple. So the first thing I do is I create a server socket instance as we discussed. And in this case, I'm going to bind it explicitly to port 9999. The next thing I do is I simply print out a message so the server will report to the console where it's actually waiting in terms of its IP address and the port that it's listening on. And then we go ahead and do the myServer socket.accept call. And this is a blocking call which will essentially block the server until a client makes a connection to this particular host and port. The next thing you see is a couple of lines. I'm just using some of the niceties in the Java.io package to make it easier to read and write to the connection once I make it. And in this case, I'm using buffered reader, which of course gives me a more efficient way to read from the underlying stream. And I'm using a print stream to actually write back on the stream. So once I have the connection formed, I'm going to go ahead and have the client, the server attempt to read from the socket connection that's resulted from the connection. So it's going to call myInput .readLine to read a line of text from that connection. And if I actually do in fact get some input, then the buff string reference here is going to be non-null, and I'm going to go ahead and attempt to print that out. And then secondly, I'm going to turn around, the server here is going to write back the string got it on that same connection, so the client will see that. And then finally, I simply call socket.close to close out that connection, and the process exits. So if we look at the client side of this, it looks very similar. Note, first of all, we import the java.io and java.net. Then here I've actually got some code up front where we're going to process some command line arguments because I need to tell the client where that server is listening in terms of its IP address and port. So by default, if the command line arguments, if there are no command line arguments, we're going to attempt to connect to localhost and port 9999. But otherwise, we're going to treat the first argument as the host, and the second argument we're going to treat as the port number. But note that's coming in as a string parameter, so I'm going to go ahead and parse it and turn it into an integer down here. If I have any problems parsing it, I'm just going to assume the default of 9999. So the first thing the client's going to do is print out this message that it's attempting to connect at whatever host port it got from the command line or by default. And then I go ahead and I create a bound socket. So it's bound in the sense that I'm giving the constructor a reference to the host of the server as well as the port. And then I go ahead and I again create my buffered reader and my print output stream based on that socket connection. Then I go ahead and I write hello sir down that socket. And I attempt to read back whatever the server sends me and then I print out, if I did indeed get something back from the server, I'll print that out, and then finally I will close the socket off and the client will exit. And notice that both the client and the server, I've wrapped the bulk of the code using the sockets with this catch handler. So any I/O exceptions, any issues I have along the way, I'll end up down here, print out a stack trace to help me see where it's going wrong, and then basically print out that I'm going to exit because of these problems. So let's try to run this application. The first thing we need to do is make sure that we have the server running. So let's go ahead and get the server running. Okay, so you'll notice here that the server is waiting for an incoming connection on this IP address and on port 9999, just like we told it. And now we need to run the client. But before we run the client, we need to make sure we provided the right command line argument. So in Eclipse here, we go down to our run configurations, and we're going to pick the simple client. If we go over to Arguments tab, we can actually see I've typed in the IP address down there where our server is, as well as the port. So let's go ahead and run this. Okay, and here we see on the bottom the output from our server. So it was waiting on an incoming connection, and when our client connected and wrote "Hello, sir," the server read it, and then it prints that "got it" message back and returns, then exits. So if we look at the console output for our client process, we can see that it attempted to connect, and then it wrote "Hello, sir," but then we see it writing out the "got it" message that it got from the server, and then it exits. So this demonstrates to us how we can use Java sockets to make it possible for two processes running on two different machines to actually connect and communicate.